2017, Paper 1, Question 2, Complex Numbers. So in this question here, we're given a complex number z, which is equal to minus root 3 plus I, and we're asked to use de Moivre's theorem to write it as z to the power of 4. So what that means is that we're given a complex number, and we're going to multiply it by itself 4 times. And then we have to make sure that we're writing our answer in the form of a plus b root ci. So in other words, we're writing it in Cartesian form. So we always have to remember to check, how do they want our answer? Do they want it in polar form or Cartesian form? So in order to raise a complex number to a power, the first thing that we want to do is draw the Argand diagram and see where does our complex number lie, and then change it from Cartesian form into polar form so that we can use de Moivre's theorem. So here we can see that the complex number is minus root 3 plus I. So that means I'm going out minus root 3 on the real axis, and I'm going up to I on the imaginary axis. So this is our real axis and our imaginary axis. And therefore we end up in the second quadrant. So if I draw back, that would be my modulus, and this will be my angle with respect to the x-axis. And if I drop that down, then what I have is a right angle triangle. So that right angle triangle, if I just mark it in green, I've gone up a distance of 1 and I've gone out a distance of root 3. So in other words, my opposite is 1 and my adjacent is root 3. So in order for us to change it from Cartesian form to polar form, we need both the modulus and the angle. So our modulus can be found if we look at that diagram by using Pythagoras. So in other words, or is equal to the square root of a squared plus b squared. And the modulus can also be written as the modulus of z. So if I sub in my values there, I have 1 squared plus root 3 squared. And even though we're going out in the negative there on the real axis, because we're squaring it, we will still always end up with a positive number, because of course our length can't be negative. So that gives me the square root of 1 plus 3, which is the square root of 4. In other words, the modulus is 2. So if I look at the angle then, so the arg of z is often referred to as the angle. Well, I have a right angle triangle, and I have the opposite side and I have the adjacent side. So to find the angle, we use tan theta is the opposite over the adjacent. So therefore, if I sub in my values, my opposite is 1 and my adjacent is root 3. So therefore, that gives me tan inverse of 1 over root 3, which is, of course, 30 degrees. So, of course, we're deciding what way do you want to write it in polar form. Are you going to work with degrees or radians? So if you're working with degrees, it's 30. And if you're working with radians, it's pi over 6. So because we always have to be able to work with radians, I'm going to do this answer and solution in radians. But you can, of course, keep it in terms of degrees. So you can check your answer at the end. But the important thing to note here is that the Argand diagram is crucial for these questions when relating to de Moivre's theorem. And that's because if you don't draw the Argand diagram, you might miss the fact that the angle isn't in fact 30 because it is in the second quadrant. So it's 30 in the second quadrant. So we say in the second quadrant, well, it's 180 minus theta is our rule. And therefore 180 take away 30 gives us 150 degrees. So of course, if we're working in radians, 30 divides into 150 degrees 5 times. So in other words, 150 degrees is 5 pi over 6. Okay, so now we have our angle and we have our modulus. So let's say theta is 5 pi over 6. Well, the next step after our Argand diagram is to write it in polar form. So our polar form is that our complex number is or times cos theta plus I sine theta. So we know that the modulus is 2 and the angle is 5 pi over 6. Or if you're writing that in degrees, you'd be writing in 150 degrees. So now we have it in polar form, we can apply De Moivre's theorem. And De Moivre said that if we're multiplying a complex number by itself, then we will raise the modulus to that power and we will multiply the angle by that power. So in other words, z to the power of 4 is going to be 2 times cos 5 pi over 6 plus I sine 5 pi over 6, all raised to the power of 4, which is, of course, 2 to the power of 4, and cos 4 times 5 pi over 6, plus I sine 4 times 5 pi over 6, and 2 to the power of 4 is 16, and cos 4 times 5 pi over 6 is 20 pi over 6, which simplifies to 10 pi over 3. And if we're using our calculators, at this point you would need to make sure that your calculator is in radians. So if we make a note, so check calculator. If you have your angle in radians, then it must be in radians. If you have your angle in degrees, then your calculator must be in degrees. So what that basically means then is that our complex number, which we raise to the power of 4, so in other words, minus root 3 plus I to the power of 4, is equal to 16 times minus a half minus root 3 over 2I. But that's not our fully simplified answer because, of course, we need to multiply out the brackets. So we have 16 times minus a half is minus 8 minus 8 root 3I. So in other words, z to the power of 4 is in the third quadrant. And just to be sure, you can obviously check this angle here. 10 pi over 3, well that's 10 times 60 degrees, which is 600. And if we keep subtracting 360, we end up with 240 degrees, which is of course in the third quadrant. And in the third quadrant, we know that cos is negative and sine is negative. So of course we can see we have minus 8 root 3I. Okay. So we had 15 marks going for that, and it's broken down into 4 parts. It was a D question. Oh, sorry. So we have 0, 5, 8, 12 and 15 marks, then max going for that question. So in B we were told the complex number W has a modulus of 3, so that's our modulus, and it has an angle of 30 degrees, so that's theta, our argument, and it makes 30 degrees with a positive sense of the real axis. And we're asked then to find t, the complex number, in its simplest form, where t is z multiplied by w. Now we already know that z from the first question is minus root 3 plus I, which we wrote in polar form as 2 cos 5 pi over 6 plus I sine 5 pi over 6. So if we write that down here, we had z was equal to 2 times cos 5 pi over 6 plus I sine 5 pi over 6, and that's from part 1. And then if we're looking at what we're given here, well, we have the modulus is 3, so W has a modulus of 3, and it makes an angle of 30 degrees. So because I have Z written in radian form, I'm now going to write W in radian form also, because it wouldn't make sense to have 1 in degrees and 1 in radians. So 30 degrees is, of course, pi over 6. So that's cos pi over 6 plus I sine pi over 6. Okay, so in other words, the modulus is or is equal to 3, and the argument of W is equal to theta, which is equal to 30 degrees, which is pi over 6. So, of course, if we're writing it in polar form, it's or times cos theta I sine theta. Okay, so what we want to do next is find t, and t is the complex number where we have z multiplied by w. So z is 2 cos 5 pi over 6 plus I sine 5 pi over 6. And we're going to multiply that by w, which is 3 times cos pi over 6 plus I sine pi over 6. So, of course, we have two complex numbers here in polar form. And if we're multiplying in polar form, well, we know that if we have z1 times z2, then it's the product of the moduluses and the sum of their angles. And again, that's not in our maths tables. We do need to know that off by heart. But of course, you could write both of these out in Cartesian form or multiply either. So it just makes, say, not in maths tables. Okay, so t then is the product of their modulus. So here's or1, modulus 1. Here's or2, modulus 2. Here's theta 1. And here's theta 2. So if we multiply 2 by 3 there, and if we add 5 pi over 6 and pi over 6, and do the same for sine, so it's 5 pi over 6 and pi over 6, then t is 6 times cos, and 5 pi over 6 plus pi over 6 is 6 pi over 6, which simplifies down to pi. And again, either using page 13 in your maths tables or using your calculators in radians. So we see maths tables, page 13. Then we know that cos pi is minus 1 and sine pi is 0. So therefore that means that t is minus 6 plus 0i, or very simply, t is equal to minus 6. So there was 10 marks going for that, and again broken down into 4 parts. So a 10D is broken down into 4, 7, 8, and then a maximum value of 10. It's a nice little question, that.